Hey everybody, today we're going to learn to factor completely and I am super excited. We have a guest speaker today, someone who you may know from your past, and if not, it'll just kind of be a fun little added enjoyment to the day, to the lesson. We got 7 problems that we're going to take a look at here, and like I'm doing in each of these videos, I'm going to ask you one question to make sure that you watched it. But for the first problem, we got a factoring problem. We got x squared, so it's a quadratic, so we're going to factor this. We've factored before, but today we're going to learn how to factor completely. So if I were to go ahead and set up my factor boxes, I would put 27x squared in the corner. I would put negative 12 in the other corner, and I would multiply the diagonal. And right now you're probably reaching for your phone. You might be watching this video on your phone and trying to grab a calculator. And yeah, I'm not great at mental math. I can show the work to do this, but you know, I'm probably gonna want to reach for my calculator to figure out what this one is. This is a tough one. I think we're gonna go ahead and go to our guest speaker for today. And let's head there right now.
Hey guys, Miss Ann Filippo here. I'm a first grade teacher over at Falls Lenox. Some of you might recognize me from your time spent there. And I'm friends with Mr. Renner. He was telling me how important it is to stay sharp and keep thinking and keep working while we're on this break from school. So he suggested I try some math problems that maybe you were working on. So let's give it a go. It's been a little while since I've been in a math class, so let's see how this goes. Here's my little whiteboard here. I'm going to write down the problem that Mr. Renner said you guys were working on. The type of problem. We got 27x minus. Okay. All right. That's the problem. Hopefully you can see it here. Yeah, this is the problem. And yeah, looks good. I'm kind of hungry. I think I'm gonna take a little break and go get a snack. I haven't eaten anything in a while, and it's not good to eat to work on an empty stomach. So I'm gonna pause this. I'll be right back. All right, feeling a little better now. Well fed. Okay, time to get to work. So I know I want to start with, I think I want to start with X. I think my mom's calling. Just hold on one second, please. Yeah, Mom? I hate to cut you off. I gotta go. I've got some math problems to solve. Okay, talk to you later. All right, back to the problem here. And yeah, it's just, you know what? I want to see how you solve this. I don't want to give you the answer. I want to see how you solve it. So why don't you show me? And Mr. Renner, why don't you send me the link to your class? Because I think I need some refreshing. Have fun.
So as you can see, Miss Ann Filippo had a little bit of trouble with trying to factor this problem. And even if she knew across that diagonal what that number was, that's going to be a pretty large number to factor. So we're going to take a different strategy. In order to factor completely, something should stand out from this original problem. We do know our factors, and we know some factors of 27. I can list those real quick. You don't have to, but I'm going to go ahead and list a few of them. We know our factors of 12 or of negative 12. And this is called a common factor. 1 is also a common factor, but 3 is your greatest common factor. This was a vocab word that was in the last video, and not too many people use this vocab to answer the question that I asked. I was hoping you would, because I knew that it was in today's lesson. But not a lot of you use greatest common factor. And again, 1 is a common factor of both of these numbers, but 3 is the greatest number that's in common in either of the lists. And that 3 is going to be the key to factoring completely. Most of the time you can just do this mentally. You don't need to make that little chart. So what I'm going to do is I'm going to start off by taking the greatest common factor in this problem, which is a 3, I'm going to factor it out front. Remember, factoring is something times something. So take a look at number 1 here. 3 times, and I'm not going to split it into 2 parentheses yet. I'm not going to split the 2 x's yet. We're still going to use the box method for that, the generic rectangle. But I know that 3 goes into 27, so I'm going to make this problem simpler. 3 times 9, x squared, is still 27x squared. I still have the same thing as the original. Now, how do I still have negative 12? 3 times negative 4. So if I do this problem, 9 times 3 with the x squared, and then 3 distribute, I've got the same problem that I had originally, but the key to this whole thing is that now I can go ahead and factor the x squared part a whole lot easier than the original problem that Miss Sanfilippo struggled with, and also I struggled with doing it mentally. 9x squared minus 4, multiply 9 times 4, that's 36. Don't forget the negative. Don't forget the x squared. This is a whole lot easier to factor, right? I know 1 times 36, 2 times 18, 3 goes in, 4 goes in, 6 goes in. That's a little bit easier to do. And then keep in mind we have 0 x's. What's the only way I can get 0 x's here? It's if I have the same number, 1's positive and 1 is negative. So I can get negative 6x's and positive 6x's will give me 0 x's. Negative 6 times positive 6 is negative 36. X times x is x squared. So negative 6x and 6x are the keys to factoring because we had 0 x's in the middle. Now I can go ahead and factor this pretty easy. I like to focus on the negatives if there are negatives, otherwise you can focus on the x squareds. But this column is the negatives. What factor goes into those? 2, we're finding a common factor. You guys, we've already done common factors. So when I took this 3 out as a common factor, the greatest common factor at the beginning, I was really just doing what we've done in these columns or what we've done in these rows before. I just did it at the beginning, so I didn't have a huge number to factor. I don't want to do 27 times negative 12. I still don't know what that answer is unless I kind of do some work or grab a calculator, right? So I'm doing a common factor here. Negative 2 goes into negative 6. How many times? 3. I also need that 3 times an x to fit in there. Negative 2 times what gets me to negative 4? That's a 2, right? So I'm doing factoring right there. I'm doing this common factoring, the same thing that I did to start off the problem, right? Now how do I factor to get to 9? 3 times a 3. I have an x times, I need another x. And then double check 3x times 2, boom. So now I factored this problem, but the key, I took out this number at the original, at the beginning, that common factor, the greatest common factor, to make the x squared factoring easier. So how do I write my answer? Well, I need this 3, that's in the original, and now my 2 factors, now my 2 x's are going to be 3x plus 2. And 3x minus 2. This is called a difference of squares if you didn't get that vocab from the last video. So we've got a greatest common factor and then a difference of squares. We have factored this completely. We've done all the factoring that we could do. The key is noticing right from the beginning that there's a 3 that you could factor out, the greatest common factor. It makes the rest of the problem then easier to factor. So what we're going to do in all these problems today is take a look if we can divide out a number, if we can factor out a number that goes into that whole list. So let's go for it. Number 2. By the way, the rest of these problems were all the ones that were in the factoring booklet or the factoring pamphlet. This was the last set, so you actually have done one of these already. You had to pick, or 2 of them, you had to pick 2 problems from the set, so you should have already done 2 of these problems. Today we're going to go ahead and do all of them. Instead of writing down number 2 over here, I'm just going to go ahead and factor completely. I'm going to take that greatest common factor. It should be obvious there's a 2 that I can factor right out of that problem from the beginning. And 2 times x squared will still give me 2x squared. 2 times 1x will give me 2x's. And then 2 times negative 2 will get me to negative 4. Now when I'm going to factor, I'm just going to factor on the x squared part right here in my boxes, and it should be a little bit easier. X squared, negative 2, multiply across the diagonal. How do I factor negative 2? That would be 1 times negative 2, or 2 times negative 1. And how do I get 1x? I would want to use this. 2x's minus 1x. So 2x minus 1x. Some people start at the x squared. I always like to go for the negatives. This is a negative and a 1 is in common. That means that needs an x. X times x gives me x squared. X times what? That would be 2. That was pretty quick and pretty easy. I bring down the greatest common factor to factor completely. Then I do my base times my height. X plus 2, x minus 1. The base times the height times that greatest common factor. So that one went a whole lot quicker. So we want to take that number out if we can. Can we do that every time? No. Sometimes you're just going to have an x squared problem and there's no number that you need to factor out. Right? We'll take a look at 3. On number 3, something should stand out already. It looks like a difference of squares problem. There's no x's in the middle, kind of like the original one. But we're going to see, is there something that we can factor out, factor completely, greatest common factor to make it easier from the beginning? Yeah, how about we go ahead and factor out the 4. 4 times x squared will give me 4x squared. 4 times negative 4 gives me negative 16. So I still have my original problem. Now this is going to be a whole lot easier than setting up 4 times negative 16 going across the diagonal. That's negative 64. That's a large number. Instead of factoring negative 64, how about factoring the diagonal here, which is just negative 4. That's a whole lot easier. 1 times negative 4, 4 times negative 1, 2 times negative 2. I could flip that. That's still 2 times negative 2. That's a whole lot easier than a list of 64, right? Factors, there's a whole lot more there. How do I find 0 x's in the middle? 2x minus 2x. 2x minus 2x. 0x, this is a difference of squares problem. I like to focus on the negatives. You might focus on the x squared first. It's your call. X times negative 2, x times 2. So easy. We bring down our greatest common factor. We bring our base. We get our height. And we have factored completely, right? Much easier than doing negative 64 over there on that, okay? Let's go ahead and do one more and we'll take a little bit of a pause. I think there's some similarities in the first couple. Instead of writing down the number 4 when you see a problem like this, you go, hold on a second. I know I can do 12 times 3, but is there a way I can make it easier? Is there a way I can factor completely? Do you guys see a number that goes into both of these? That'd be 3. We're going to go ahead and factor out a 3 to start. 3 times, how can I get to 12? That would be 4x squared. 3 times, how do I get to negative 3? That would be a negative 1. So 3 times 4 is 12x squared. There it is. 3 times negative 1 is negative 3. We have our original problem. It's just going to make the factor boxes easier to do. I'm just trying to make your life easier for you today. So we're going to take the 4x squareds. We're going to take the negative 1. 4 times negative 1 is our diagonal. That's the key to factoring. Hey, look, we got the same factors of the problem before. Did you guys see a way to get 0 x's? Oh, the same way that we did on the last one, 2x minus 2x. All right, so we're going to have a pretty similar problem to the last one. Last time I did the x squared, this time I'm going to do the negatives. I always like doing the negatives. Here's negative. What else is in common? Just a 1, right? Negative 1 times, I already have the negative, so I need to go times 2, and then I need the x. All right, so 2x times negative 1 is negative 2x. How do I get to 4x squared? 2x times 2x. 2x times what? Gets you to 2x. That's just a 1. We've now factored. I'm going to bring down the greatest common factor. This is always called, or often called, the GCF in books, or your math teacher might reference it, the greatest common factor, the GCF. And then I do my base times my height. And we have factored completely. Cool, we're going to take a little pause here. I'm going to show you a problem that popped up on the state test last year, the year before, and you're going to see how the options have factored completely. This is your problem that you need to turn in the answer to me to prove that you watched the video. So here's your little break point. Hopefully you had a good little break. Hopefully you were right with that question from the state test that was released a year ago or so. Hopefully you had a good break. Like Ms. Sanfilippo said, it's good to take a snack. So hopefully you're staying healthy. Eat some good things. Don't just eat a bunch of chips while you're sitting on the couch watching Netflix. We're going to move on to number 5. My mouth is full, so I'm just going to go ahead and do the work. Alrighty, so I factored out a 3. I saw 3 as the greatest common factor in this problem. Factor the 3 out. Now I just have a nice easy x squared problem to factor. Go across the diagonal. And sometimes kids get tripped up with the 5s and 6. It's kind of a weird problem when you have the 5s and 6. I need negative 5x's, and I do not see negative 5x's. Some people will put the negative there, and that will be incorrect, because negative 1 times 6 is not 6. The key to the whole problem is the diagonal. I need to end up with 6. The diagonal is 6x squared. I got a positive 6. So I cannot put a negative here, right? If I want negatives, I got to put them on both. Negative times negative is back to a positive. That's the key. The diagonal is the key. I'll get to negative 5x in a minute. The diagonal is the key. It's got to match up to that, right? So if I need negatives, and I don't have one negative to use, I got to make them both negative, so it turns back positive. Now that I have both of these options, now I see a way to get negative 5x. It was not 6 minus 1, right? Or it wasn't 1 minus 6. The way to get negative 5x's is right here. Negative 2x's and negative 3x's. I do have some negatives in here, but I don't have a negative column. I don't have a whole negative row, so I'm going to go to the x squareds. X times x times negative 2, x times negative 3, negative 2 times negative 3, boom, there's our 6. Bring down your greatest common factor, and we have factored completely as long as we write our base times our height. Doesn't matter what order you do them in, that is factoring completely. You should have seen something like that happen on that state test question just a minute ago. Cool, we're almost done. Heading into number 6 and number 7. In number 6, take a look at what you might think be a greatest common factor. I have found a factor. I have found a common factor. But did I find the greatest common factor? Nope. The greatest common factor should have been a 9, right? So I can factor like this, but I'm not factoring completely. You got to find the greatest common factor that can come out of that problem. Right? The greatest common factor that can come out of that problem is a 9. Now it's going to make it easier because in those boxes, now I just have an x squared problem. The x squared ones are the easiest. I can even do this right now before I do the rest of the box, right? Minus 1, negative 1 x squared. What's the only way to factor negative 1? That's it, right? So I'm looking for 0 x's here. That's easy. 1x minus 1x. 1x minus 1x is no x's anymore. There are no x's in that original problem. There's x squareds, but there's not any x's. X times what? Negative 1. X times what? Just a 1. Bring down your greatest common factor. Bring down your base. bring down your height, and we have factored completely, right? So if we would have factored the 3 at the beginning, we still could have factored the boxes here, but we would not have factored completely. It would not show up as a multiple choice answer on a state test. So we want to make sure that we can factor completely. And then we head to the last one. This problem, there's some big numbers in there, right? I would not want to factor this the way that we were doing it before. The way that we were doing it before, our boxes would have looked something like 15x squared negative 6. What is 6 times 15? 6 times 10 is 60. 6 times 5 is 30. 60 and 30 is 90. Do you guys want to factor negative 90? I don't. It's going to be a lot of numbers. I mean, I can do it. 9 times 10 or 9 times negative 10. 5 times 18, 1 times 90, 2 times 45, 3 times 30. But then I got to worry about a bunch of negatives. That's a huge list that's happening, right? When you factor completely, you make the problem easier for yourself. Does everybody see a 3 goes into all those? Let's go ahead and make it easier on ourselves. Let's factor out a 3. 3 times 5 will get me to 15. 3 times negative 9 will get me to negative 27. And 3 times negative 2 will get me to negative 6. I have the same problem. It's now just going to be easier when I do the generic rectangle. 5x squared, negative 2. The key is the diagonal. Negative 10. Isn't negative 10 a much easier number to factor than negative 90, right? I'm going to go ahead and just list the negatives already on both sides here because the list is so small. Now it's easy to just write 1 and negative 10 and 10 and negative 1. 2 and negative 5 and 5 and negative 2. It didn't take me that long to just switch the negatives. Do you see a spot where you get negative 9x's? I think it'd be that one right there. So if I had 1x minus 10x, that would be negative 9x, right? I always like to start with the negatives. If we have a negative row or column, we do. That is negative 2. How many times does negative 2 go into negative 10? That would be 5. I do need the x there. 5x, how do I get to 5x squared? Just an x. X times what gets me to 1x? 1. 1 times negative 2. Boom, there's our last part. So how do we factor completely? We do the base times the height. And we don't forget the greatest common factor so that we have factored completely. There's your last problem. Again, don't forget to go back. I took a break about halfway through. There's a state test question. That is the question that you're answering to make sure that you got this topic, that you understand it before our quiz. All right, have a great week, and remember to eat healthy.